This question involves transforming a function, and in this case it's without using the graph, so there's no visual solution to any of the parts of this question. So let's look at the question here. We have a curve C, y equals f of x, such that f of x is 9 minus 3, and in brackets x plus 2, which is squared. Point A is a maximum point on C. And it says write down the coordinates of A. So we want the coordinates of the maximum point. So we want this function to be at its largest. Now if we just look at the function here, we have 9 taking away something. And this thing we're going to take away, whatever we do to x will end up being squared. So the value of x will get bigger, or the value of this bracket will get bigger and bigger and bigger because we're squaring it and we're multiplying it by 3, and then we're taking it away. So the larger we get this, the smaller our value of f of x. So we want this to be as small as possible. And for that to be as small as possible, we must have our x minus 2 must be equal to 0. So we need x plus 2 to be equal to 0. So x equals minus 2. When x is minus 2, the bracket will be equal to 0, so we will just have a value of y being, or f of x being 9. So f of minus 2, you would have 9 minus 3 multiplied by minus 2 plus 2 squared, which is 9 minus 0, which is 9. So my coordinates will be, my x value is minus 2, my y value is 9. Now in the exam, you do not need to do any of this writing. You just do this thinking process in your head. You just look at this, analyze this, and write down the two coordinates, the x coordinate and the y coordinate for our maximum point. Now in the second part, it says that curve C is transformed to curve S, so it's moved, by a translation of 4, 0. So 4, 0 means that we're going to move to the right 4, but we are not going to move up or down. So if you remember, when we are moving a function, moving a graph to the right, we are taking away within the function. Okay, sounds a bit counterintuitive, but that's what we have to do. We take away within the function, we move to the right. If we added inside the function, we would move to the left. So we take away within the function itself. So our s will now be equal to 9 minus 3. So we take away 4 from our x, so it's x minus 4 plus 2, and then that would be squared. So s will be equal to 9 minus 3, and we have x minus 4 plus 2 is minus 2, and that will be squared. And that's all you need to write for the mark in the exam. Again, you can go straight to the solution. Make sure you think carefully, what is this translation doing? If movement to the right, we'd subtract 4 from the function itself. So we take 4 away from our x value, as it is here. If this was, say, a negative number, then what we would be doing is we would be moving to the right. So we would be adding into this function. But this case, it's the opposite. Finally, again, we have to think about this one, where we have the curve C, so it's back to the original curve again, is transformed to t, such that the equation for t is 3 bracket x plus 2 squared minus 9. It's very similar to this, but if you look at it carefully, it's the negative of it. Because what we have here, if we take our f of x and we put what is negative f of x, we would have negative 9 plus 3 bracket x plus 2 squared, which is the same as saying 3 x plus 2 squared minus 9. So we have negative f of x. If you think of a graph, if you plotted a graph and you had a whole series of y values, you would have one function. If you then multiplied all of those values by -1, our y values would then become the inverse y value, would become the opposite. And what we would end up doing is reflecting in the x-axis. So a reflection in the x-axis is our solution, and that's what we're looking for in the exam. If you're not sure, have a little play around with the software GeoGebra, because GeoGebra You can put different functions in, you can change the numbers, and you can actually start to see how all of these transformations work. Get really familiar with this, and then these are 3 very, very quick and easy marks to get within the exam.